Okay, so we've been doing a ton with factoring, and now we're going to actually use that factoring to do other things. The thing we're going to be looking at today is solving quadratic equations using factoring. So in 3-4, there are two different quizzes. The first one is going to contain things like example 1, and then the second one has example 2 and 3. So in the ones like example 1, we're focusing in on the zero product rule, which it's important that you know what the zero product rule actually says. And it says if A times B is equal to 0, then A equals 0, B equals 0, or both A and B equals 0. The reason why we call it zero product is because we have multiplication, which means product, and we know that in order to get 0, at least one of them has to be equal to 0. So that's where we get this statement. So I think it'll even ask you about what the rule states. So everything in the first quiz is already in what we call standard form, which is this guy, ax squared plus bx plus c equals 0. So this is now an equation, not just an expression. So all the factoring we've done up to this point has just been expressions, no equal sign. Here we're going to have the equal sign. Specifically, they're going to be equal to 0. So since they are already equal to 0, the process for us is going to be number 1, factor it using all the factoring rules we've learned. Then set each of the factors that we get equal to 0 and solve them. So most of the time when we're solving quadratic equations, we are going to get two solutions because the exponent is 2. Now we will do at least one here where we end up with only one solution. But most of them are going to have 2s, so you're going to see a lot of the select all that apply, and typically you're going to be selecting 2. So find the solutions to the equations below. So first we need to factor it. So we kind of go through this little checklist of factoring every time. First thing you should always look for is a GCF if there is one. So I look at all 3 terms here and I see that there is no x in the last term. I see that 5 is prime and this one's a 1, so no GCF here. So then I would look to see if it's one of my special cases, the ones we just did where we had difference of squares, perfect square trinomials, sum and difference of cubes. So since this has 3 terms, the only one it could possibly be would be a perfect square trinomial. But if you look at that checklist that we wrote down, that would require that the first and third terms both be positive and both be perfect squares. This guy isn't positive and it's not a perfect square. So that means we're going to go on to our chart factoring because it's a plain x squared. So we're looking for factors of negative 14, and then we're going to find their sums. So because it's negative, we kind of have 2 pairs every time. Switching up the signs, so I've got the 1 and 14 double pair. Then it's also divisible by 2, so negative 2, positive 7, or positive 2, negative 7. It's not divisible by 3 or 4 or 5 or 6, and now we're back around to the other side. So this is it. When we do all the sums, the winner is the one that's going to give me positive 5. So that's these ones. So those are my winning numbers. So it's going to be x minus 2 times x plus 7. Now remember, this trinomial factored into this. We still have the equals 0. So we factored it. Now here's where we use the zero product rule. We have a product of 2 things that is equal to 0, which means that either the first factor, x minus 2 equals 0, or x plus 7 equals 0, or they both equal 0. So we set each of them equal to 0 here, and now we're just going to solve. So here I'm going to add 2 on both sides. Here I'm going to subtract the 7. So x equals 2 would be one answer, and then x equals -7 would be the other. I really caution you, make sure you do all 3 steps. What ends up happening sometimes is kids try to skip steps, and then they look at this and they say, oh, -2 and +7. Nope, those would not be the right solutions. And you can guarantee if it's a multiple choice that those are going to be choices. So make sure that you work out all 3 steps. All right, now let's go on to this next one. So as I said, we always look for GCF first. So here I do have one because both terms are divisible by 3. So take the 3 out. 3x squared divided by 3 is x squared. 48 divided by 3 is 16. So my first step of factoring looks like this. Now, just because you've done one step does not mean that you're done. So I now need to look at what's left in the parenthesis and see if I can factor it any further. This is a binomial. So after GCF, I look for my special cases, and we learned 2 types that were binomials: difference of squares and sum difference of cubes. So since this exponent is not divisible by 3, we'd be looking at difference of squares. So x squared, does that have a perfect square root? Sure does, it's x. 16, does that have a perfect square root? Sure does, it's 4. So this is a difference of squares. Remember that difference of squares, it's 2 parentheses. The front square root goes in the front. The back square root goes in the back. And then one symbol is a plus while the other is a minus. Now, here's where we have to be careful with number 2, and I'm purposefully picking examples that illustrate different things. This GCF does not have a variable, so I do not need to set it equal to 0 because it's not going to produce any solutions for x. So I focus in on the x plus 4 in step 2 and the x minus 4. So I set both of those equal to 0 and then solve them. Here I'm going to get x equals -4 because I'm subtracting to get x alone. Here I'd be adding to get x alone. And so we get x equals 4. Now, please keep in mind, if this GCF had had an x, for instance, then you would have to do 3x equals 0. Divide by 3 and get x equals 0. But in this case, we didn't have that. All right, now let's look at C. So first I look for a GCF. No x on this one, and 10 and 3 don't have any common factors other than 1. So I know that this is not GCF. Then I look for special products. It's a trinomial, but this guy is not a perfect square and it's a minus. So not special products. I cannot chart factor like I did in A because it's not a plain x squared. So that means because there's a number, it's an ax squared, that I'm going to have to do the guess and check method. So factors of 10 are 10 and 1, 5 and 2. Factors of -3 are -3, +1, +3, -1. So I'm now going to guess and check them in the parentheses. So if I try, I always start with the ones that are closest together first. So I'm going to try 5x and 2x first. Remember that we're not allowed to have any common factors, so I can put the 3 here. It and 5 don't have any issues, so I'm going to try just what's at the bottom first. So +3 -1. When I look at the outsides and insides there, that gives me -5x plus 6x, which is 1x. So that's not what I want. So again, the point is guessing and checking. I can't get rid of, I can't cross off this guy yet until I try the plus 3 and the minus 1 in opposite locations. So now we'll check. This would give me 15x, and this would give me negative 2x, which would be positive 13x. So notice that I want negative 13x. So this means I have found the correct placement of the 3 and the 1. I just need to switch the signs. So I'm going to go back here. I'm going to make this plus 3 into a minus 3, and I'm going to make this minus 1 into a plus 1. So now that would give me positive 2x here and negative 15x here, which is negative 13x. So I guessed, I checked, I know it's right. So now I'm done with step 1. I can now move to setting each of those equal to 0. So 5x plus 1 equals 0, 2x minus 3 equals 0. These ones, because of that number in front, are two-step equations. So in step 3, I actually have to do 2 steps to get the x alone. So first here I'm going to subtract the 1, so 5x equals negative 1. Over here I'm going to start by adding 3. 2x equals 3. And now I need to divide. Divide by 5 here, divide by 2 here. So I end up with x equals negative 1/5. Your answers in the quiz will be fraction form, so don't give decimals. Here I end up with x equals 3/2. So I've got 3/2, negative 1/5 for my 2 solutions there. All right, so that right there, if you are ready to take the next quiz, you could pause it. Example 2 and example 3 are going to be in the converting to standard form quiz. So we already talked about what standard form is over here. Ax squared plus bx plus c equals 0. So you're going to have some that just simply ask you to put it in standard form. Remember that we have to follow order of operations. So if I look at my PEMDAS, first would be what's inside the parentheses. Inside the parentheses, I have 7x plus 2. Those aren't like terms, so there's nothing I can do with that. So I can cross off the p. Next, I'm going to go to E, exponents. I do have exponents here. Please be careful, guys. This is a binomial. When you have a binomial squared, it has to be FOILed. You can't just square the 7x and then square the 2x. We only do that when that's multiplication. So here what I need to do is just copy down the rest. And now I need to FOIL this. So 7x plus 2 times 7x plus 2 firsts would give me 49x squared. Outsides and insides are both going to give me 14x because 7x times 2 is 14x, and I have that twice. So 14x plus 14x is 28x. That gives my outsides and insides my lasts, 2 times 2, which is 4. So now I've done the exponent. So now multiplication and division. So this isn't multiplication, but this is. So go ahead, and multiplication in this case means that I'm going to distribute that 3. So 49 times 3, well, 50 times 3 would be 150. It's going to be 3 less than that. So 147x squared. Then 28 times 3 gives me 84. So 84x, and then 3 times 4 gives me 12. Now, when we put something in standard form, so we did multiplication, there is no division, now I do the addition and subtraction. Well, these are like terms, so I can't add or subtract them as is. So each side is as simplified as it can get using PEMDAS. Now I need to focus in on the equals 0 part. So it doesn't really matter if the equals 0 is on the right or the left side. So here, because I have 3 terms on the right and only 2 on the left, I'm going to move these two over. So subtract x, put it under its like term, subtract the 5, put it under its like term. These both go away. Now when I write it, I'm going to write this part on the left because it's equivalent. So 147x squared, 84 minus 1, so that's 83x. 12 minus 5 is plus 7, and it is equal to 0 because I canceled both those things over there. So this would be the standard form equation. All right, last example, still finding solutions to the equations. In this second quiz where we are focusing on converting to standard form, we're going to have ones that we're going to have to use the zero product rule, just like in example 1. But before we can do that, we have to put it in standard form. So because this isn't equal to 0, I need to subtract the 5x over here and write it 6x squared minus 5x minus 4 equals 0. So I look for a GCF. There isn't one. It's not a special product because this right here is a minus and it's a trinomial. So that means guess and check. So 1, 6, 2, 3 are the only factors of 6. For negative 4, it could be negative 4, positive 1, positive 4, negative 1, or positive 2 with negative 2. So now I'm ready to guess. So again, I usually start with the ones that are closer together. So I'm going to start with the 2x and the 3x for my first guess. And I know it can't be the 2 and the 2 if it's 2x and 3x, because that would require me to put a 2 with the 2x. Those would have a common factor. So I'm going to try the 4 and the 1. Again, the 4 can't go here because 2 and 4 have a common factor. So I'm going to try negative 1, positive 4 right here. And so that's my guess. Now I'm going to check it. So this would give me 8x. Inside gives me negative 3x, which gives me a total of 5x. Again, I have found the right number, but the wrong sign. So all that means is I'm going to change this minus to a plus. I'm going to change this plus over here to a minus, which means this is plus, this is minus, this is minus. And so now I do get negative 5x, which means go ahead to step 2, set each of my little factors equal to 0. So here, subtract the 1 first, gives me 2x equals negative 1. Here, add 4, gives me 3x equals 4. And then divide by 2. So x equals negative 1/2. Divide by 3 over here, x equals 4/3. So negative 1/2, positive 4/3 are my two answers there. Same process that we're going to use here. Notice this time I've got 3 terms on each side. So in this case, because I have multiple x squared terms, remember that when I was going through just our factoring, one of the things I said is that we always need our squared term to be positive. So because of that, I'm going to move this over here, which means I'm going to move all the other ones over there too, because it has to be equal to 0. So subtract the 4x, subtract the 6. So that gives me x squared minus 10x plus 25 equal to 0. So has to be equal to 0 before I can factor. All right, so now looking at factoring, first I look for a GCF. They don't have x's in common, and this is a 1, so they don't have anything else in common either. Next, I look for my special cases. It's not a binomial, so it can't be difference of squares or some difference of cubes. Trinomial would be PST that I'd be checking for. So first and third terms are both positive. They also are both perfect squares. Square root of x squared is x, square root of 25 is 5. Remember that on PSTs, your middle term has to be in the form either 2ab or negative 2ab, where a and b are the square roots. So if I do x times 5, that's 5x. If I double that, that would be 10x, because times 2 means to double. So I do have this format. I have negative 2ab here. So this is a perfect square trinomial, which means that square root of the front goes in the front, square root of the back goes in the back, and the sine of the middle goes in the middle. Now remember, you can either write it with just a squared, which is what I usually do because that's simplest form, or you can write it x minus 5 times x minus 5. They mean the same thing. It doesn't matter which way you do it. Either way, the two factors are the same. So when you go to set it equal to 0, you really only have one thing, because even if you write it twice, we're not getting a different answer here. Both times I get x equals 5. This is what we call a double root when you have the same factor twice. So this is a case where even though it's quadratic, I only have one solution, and that's because it's a double root. It's a solution that happened twice. So make sure that you're looking and paying attention to those when you go to do your quiz. All right, that wraps us up. So make sure you reach out if you have questions.